So, first of all, can somebody let me know if you can hear me and if you can see my screen?
Yep.
Okay.
Gotcha.
Okay, couple things. Just before I forget to mention it to you, there are some labs on today's module that I actually opened just so you can do the questions on them. Do not fill in anything on any of the shop work on the labs that are on today's module. That's stuff you're going to have to do in the shop when we get back on campus. Does anybody have a question on that?
Actually, just one. I haven't been able to open up Lab 2 Alpha. It keeps cycling, but nothing opens up. 2 Bravo and 2 Charlie are fine.
That's how mine is, too.
Same issue?
Yeah.
Yeah.
Okay, hang on one sec. Where does it cycle? When you first go into it, or?
When I click the Lab 2 Alpha right there.
Right there?
Yep.
Oh, that's just awesome.
Yeah, all I end up getting is the spinning ball.
Yep, same.
Are you also using the app? I use the app.
Yeah, I'm using the app.
Okay.
Yeah, it doesn't. It should. Okay, I'll have to. Okay, let me do this real quick, and we just solved the whole problem. You said 2 Alpha?
Yes.
My guess is there's 2 versions of it. So let me just take care of this real quick. Where the hell is it? There it is. Okay. I will take care of that real quick. It shouldn't be showing up on your work anymore. Okay. And I will probably replace it, but it won't show up till tomorrow. Okay, so don't worry about 2 Alpha.
Okay.
Okay, by the way, if anything like that ever comes up, could you do me a major favor? Because sometimes I forget to mention things on calls. Could you just drop me an email or something like that and just let me know?
Okay, is it okay if I emailed you at night? Because that's when I try to...
Oh, yeah. I'll see it first thing in the morning because some of you guys start doing this stuff at 2 a.m. at night or in the morning, but I'll see it first thing in the morning, and I'll make sure I either mention it on a call or I'll take care of it, okay?
Okay.
You won't get an immediate response from me if it's past 11 o'clock at night before 6:30 in the morning. It's just not happening.
Oh, no, I wouldn't even try it.
So, but that way I can take care of it. So, okay. So having said that, the labs are out there. Again, don't deal with anything that's on the, okay, I can't remove it there, but don't think I can. Okay. Don't worry about the readings from the shop stuff. You obviously can't do it at home, nor do I want you to try to do it at home. Okay, if you have an oil burner. Don't try this at home. Okay, we really want you to be working on this stuff once you're back in the shops. There are some questions on the videos and some stuff like that. There's a tank inspection video out there. There's some other stuff out here. There's a question of the day. Please make sure you take care of that stuff, okay? Today, I want to talk about filters. Okay, it's not going to be a long session today. We're going to talk about filters. There isn't a lot to filters, but there's some things we do have to talk about. I do want questions. I need this to be interactive. I am going to mute people that I have a lot of background noise on, so do me a favor, mute yourself and unmute yourself as needed if to ask questions or be involved in this conversation. So having said that, let's talk about oil filters. Again, there's 3 relatively short PowerPoints that I do want to have some conversation about. Okay, we have to have an oil filter. Okay, oil as it comes off the truck is not clean. Okay, oil is probably, I hate to say it, one of the dirtiest parts of the trade, but oil itself is not clean. Okay, oil tanks have dirt particles that build up from the moisture in the tank, little particles of oil, gel, oil that comes in off the fuel truck, has some sediment in it. It is not clean. The particles that are in the oil can restrict the small passage in the nozzle, so we have to filter oil before it goes to the nozzle. Okay, oil filters are changeable. Okay, the most often used oil filters out there have a changeable cartridge in them. Okay, and it looks like this. Okay, the filter cartridge, which is the inside white portion, okay, should be changed out on a yearly basis. Okay, this area here gets changed out on a yearly basis. When the filter is serviced, it's a good practice to replace the filter case, to fill the filter case with oil before putting the cartridge on. Okay, this whole area around here in this casing needs to be filled with oil. If it isn't filled with oil, what do you get in your oil line in large quantities? If I don't pre-fill this with oil, what am I going to be having to do with my oil line? Guys?
Because there's air in it, you're going to have to purge it.
Oh, I'm going to have a ton of air. There's a lot of air in this thing. I'm going to have a little bit of air no matter what I do. But it's much easier to get a little bit of air out of my oil line than this whole container of air out of my oil line. Okay, we don't want to have to pump that much air out of the system. I don't want to need to spend an hour bleeding a system because I was too lazy to fill this with oil a little bit. Okay, now, if you look closely at this cover, okay, I'm circling a little screw, a little nut that's on this cover. It's right there. Okay, that is a little screw that will actually, once you put this filter assembly back together, you can actually bleed the air out of the oil filter right there without having to bleed it through the pump. You loosen that set screw, okay, and it actually allows you to bleed the air out. Now don't take that set screw out, or you're going to have 275 gallons of oil pressure shooting at you out of that filter. But if you loosen it, you can bleed that out. The other very important thing that I got to tell you guys about is there's a gasket around this. Okay, and I'll just remove my scribbles there. And if you look closely there, there's a gasket right around this. It's a black gasket. When you're supplied with the new filter material, you get the filter, you get the gasket, and you get a replacement gasket for under the big nut, the big screw and nut that hold this back together. There's a little washer there with a gasket under it, and you get a replacement gasket for under that bleed screw. All three of these gaskets that are shipped in the bag with the filter need to be replaced. Okay, now, every one of you, when you go into the oil field the first time, second time, or someplace down the road when you service a piece of equipment, you're going to get to a filter that this gasket has been on there so long that it may not fall off easily. Okay, and if this is black, if the filter container is black and there's a black gasket there, you may forget that there's an extra gasket there. Okay, always check. What do you think happens when there's a double gasket?
Doesn't get sealed well?
Well, part of it is it doesn't get sealed well. What else can happen if you put pressure on two rubber gaskets that are together?
Leakage.
You have two rubber gaskets and you put pressure on it. What happens?
Leakage?
Expansion?
Well, no. Actually, all of it is a good answer, okay? But the bottom line is it's going to push those gaskets out of position. Okay, within an hour, it's going to push those gaskets, that pressure you've put on as you've resealed that. Okay, it is going to push those gaskets out of position. Now, this filter is on the bottom of a tank of oil. What's going to happen when those gaskets get pushed out of position?
It's gonna leak.
It's going to leak. How much oil are you going to have on your floor?
A lot.
Is it?
Yeah, it becomes a relatively big problem. Okay? Happened in my house. Okay, way back when I lived up in Hartford, happened in my house. Okay, so just that's one of those things. And who's at fault if that happens?
The technician.
Technician who did it, yeah. Okay, it's very easy to prove that there's a double gasket there because the person who comes behind it is going to have to come up with a reason for the spill. And when you pull that filter apart, you can see that there's two gaskets. So, again, be very, very careful about double gaskets. Okay, be very, very careful about anything around the filter that can leak. By the way, can these filters be put in backwards?
No.
It doesn't look that way.
Okay, if you look closely at this cover, and again, I know it's hard to see. Look where I just circled. Okay. Sorry, I did have to mute somebody. If you look at where I just circled on this, okay, if you look closely at the metal, it's stamped in and out. Okay, these have to be put in the right direction, the inlet side and the outlet side. Filters will not work backwards. Okay, so just be careful about the filters. Okay, if we pump too much air through the oil pump is going to get damaged. Okay, we can also add a second oil filter, and it can be placed in the line between the pump and the nozzle. Does anybody remember what the name of the line is between the pump and the nozzle? I've said it a few times. Does anybody remember what the official name of that line is?
Is it the fill line?
The what line?
Fill?
No, that's on the tank. That's going to be between the outside and the tank. Let's think about on the burner side. The pump connects to the nozzle via what line? Starts with a J.
Is it the J tube?
Not exactly. Starts with a J, but there's two more letters. What line?
J line, I guess.
How about jet line? J-E-T. Jet line. Jet line is the high-pressure quarter-inch oil line between the pump and the nozzle. Okay? So you can actually put an oil filter right in the jet line. You should never need to do this, okay? The oil filter, if you install it there, it removes pump shavings before they reach the strainer at the nozzle inlet. Now, I have never had a situation in the field where I've needed to remove pump shavings. Okay? Pump shaving basically means the pump is failing, and if I have metal shavings coming out of the pump, what's the right thing to do?
Replace the pump.
I would replace the pump. Okay, this is one of these situations makes no sense to me. Okay, oil filters can be made up of two materials, cotton and a fiberglass type material. They both work extremely well. These filters have been in use for years. Okay, the fiberglass material is the white-like material on the left. The cotton material is on the right. Okay, again, extremely important. You've got to replace the gaskets. Okay, the gaskets are designed for one-time use. You open the filter container, you replace the gaskets. Don't be lazy. Okay, it's much easier to take that 5 minutes. You have it open anyways. Okay, what do you do with these filters when you've removed the old ones? What do you do with them?
Put them in a plastic bag and get rid of them.
Where do you get rid of them?
Blah, blah, blah.
Are you going to toss them in the customer's trash can that's in the
No,
basement?
no. It
Put them
comes
in your
with
van.
us.
Yeah, get them out of the house. Okay, what's the one thing customers with oil heating systems hate to smell?
Oil.
Oil. Seriously. If you can avoid the customer smelling oil when you're done with the service call, that is the one largest complaint service companies get when they're dealing with oil. The customer smells oil. And the minute they smell oil, they think there's a leak. Okay, so get these things out of the house as fast as humanly possible. Okay? Also, when you're doing an oil service call, how are you going to be entering and leaving the house with your oil equipment? Are you going to walk it through the front door all the time?
And go through like Bilko doors and shit.
Yeah, you're going to go through bulkhead doors and stuff like that. You're not going to walk it all the time through the front door. You don't want to do that. Okay? You want to go as little as possible through the main house. Okay, I know a technician who was a very experienced oil burner tech, unbelievably experienced, knows it all. He's my go-to guy still to this day when I have a question on oil that I can't figure out. Okay, my go-to guy for oil. Okay, he was carrying a bucket of used oil out of a house, and there was no bulkhead door. And he had to carry the bucket up the basement stairs and out the front door. He dropped it as he tripped over a step. Okay, bucket of oil fell down the stairs and obviously broke open. The cover broke open, and it cost the company very close to $50,000 to clean it up.
Whew.
It was a total accident. Tech was not blamed. Tech was 100% innocent. Okay, because the bottom line is the customer had a loose piece of carpet on the steps. But again, just be very, very careful with oil in people's houses. I know another technician who in a finished basement, everybody knows what a finished basement is, right? They put carpet down, they made it into their little playroom or whatever. The lady had white carpet in her finished basement. The technician was using the bulkhead door like he was supposed to, okay, and stepped in mud outside the house and left perfectly good mud prints across the white carpet floor, okay, from his work boots. Be very careful about stuff like that. Okay, it's not necessarily your fault, but you're going to be blamed for it anyways. So just be very aware about customers' houses. Okay, there's one third type of filter. I don't have a slide for it. Anybody know what it is?
No idea.
Okay, I didn't know if you got it in your reading yet or not. Okay, there's one third type of filter. Everybody knows what a car oil filter looks like. The whole filter assembly that you just screw on and screw off. Everybody's seen one of those? It's just the enclosed filter.
Yeah.
Okay, we're starting to see those used quite a lot in oil. They make them now for oil furnaces. They're Gerber filters, almost like the baby food name. Okay, Gerber filters. Okay, they actually are just a cartridge filter. Okay, they're very easy to deal with. They're very effective, and they're the high-end filters. So if you ever have a situation where a customer constantly gets dirt and stuff into their oil filters, their pump filters, okay, and it gets past these filters, okay, I always recommend going to the Gerber filter. Matter of fact, when I was up north still and installing some oil equipment, I always changed out to the Gerber filters. I got rid of these filters because the Gerber filters are that much better. Okay, they actually absorb some water as well that I liked. So I don't have a slide for those, but the cartridge filters, they are coming more and more frequent. If you can use them, use them. Okay, but they're a little bit more expensive.
Are all these filters compatible with the same casing, or does the casing also have to be swapped out?
These two filters that you see on the screen now are compatible. Okay, if you go to the cartridge filter, it's a different casing.
Okay.
okay, which isn't a major deal. It's 2 pipe connections, okay? It doesn't take much to swap them out,
Right.
okay? But the cost of these filters, when I purchase these in, like when I purchase them in bulk for our shops, okay, I'm paying about $1.25 a filter.
Nice.
Okay, the Gerber filters I pay about $4.50 per filter.
As long as they last.
Well, they last. We leave them on the same amount of time. Okay, still we change these out once a year. Okay, they're annual, but what they give in protection and oil flow is worth it for the newer filter. Also, quite honestly, I don't get as full of oil if I'm changing a cartridge filter out versus this. Okay, for a service perspective, I don't have a bigger chance of spilling oil. Because when you take this filter assembly off, okay, let me go back a slide. When you take this filter assembly off, this whole filter assembly, this whole outside case is full of oil. Okay, so you take this off. This is the cover is mounted to the oil line. You loosen this bolt, this whole assembly pulls down off the top. This whole thing is full of oil. Okay, you put some sort of bucket, or I used to use a pie plate. Okay, with where people bake pies in it. Okay, I used to use a pie plate to slide under here because when you separate these 2 pieces, you always get oil that flows out. Okay, if I have a cartridge filter, I'm still going to get the oil, but I'm not going to have this whole thing that I have to empty and clean out. Okay, I'm just going to be able to pull it apart, put the new cartridge filter on, spin it, bleed it, and I'm done. But this, I actually have to dump the oil out of the inside of this. I have to pull this apart, and then I have to clean the sediment out of the bottom of this filter housing. So again, that's why the cartridge filters, if you can go to them, okay, I always did it as an upgrade for the customers because it's a better filter. There's nothing dishonest about it. So that's just, again, filters. Okay, pretty easy, right? Nothing much to filters. There to filter the oil. You got to bleed the air out of them. Okay, so again, there's not much to them. Now, we do have another little thing that goes along with filters, okay, that I want to talk about. Let me just swap this out. Okay, what's one of the worst things I can have in my oil line?
Water.
Blocked oil.
Okay, I heard a couple different answers, but what's the worst thing that I can have in my oil line?
Air.
Air. Okay, so air is one of my worst things that I can have in my oil line. Okay, so what I want to talk about is oil line de-aerators. Now, as far as I'm concerned, okay, and this is a very heavily opinionated statement, okay, if you have air in your oil line, you have a leak someplace. Okay, but this, what I'm going to talk about, is something you're going to see frequently, but it's a Band-Aid. Okay, the real solution is to find out where the air is coming from. But in some larger commercial areas, and in some areas where we know there's no leak, okay, and if there's still air somehow getting in the oil line, perhaps from the tank, perhaps just from too much equipment on an oil line or whatever, we use what's called an oil fuel line de-aerator. Okay, what it does, it removes air or bubbles from the fuel so it doesn't cause problems. Okay, we have to have, for any oil equipment, we have to have equipment that's well maintained, and we have to have fuel that's free of contaminants, dirt, water, or bubbles. Now, where do I get rid of the dirt? What pulls the dirt and the water out of the system?
The filter.
The filter. What about air bubbles? Can air bubbles go through the filter?
Yep.
Yeah. So we need something else occasionally to remove bubbles. Again, the ideal spot, and I'm going to keep saying this, is to make sure you don't have bubbles in the first place. Okay, but if you're in a situation where you just can't get rid of the bubbles, okay, we have to figure out why there are bubbles. First of all, air bubbles, okay, is either a leak in the system or bubbles that were delivered with the fuel. Okay, air bubbles in the oil are a result of the oil being churned up during the loading, transporting, or delivery. Okay, every oil system out there, when fuel is delivered, will have air bubbles. It's just part of the delivery process. The other source of bubble is basically gases that are drawn out of the oil when it's under the vacuum. In other words, if I have a very high vacuum in my oil line, so if I have a vacuum that's being pulled that's about 15, 20 inches of vacuum on a two-stage pump, in other words, it's at the maximum vacuum, I can actually cause bubbles to form in the oil line when it's under a vacuum. Okay, you've got to be careful of that because it might not be air. Okay, so we have to solve the problem. Okay, so the air in the oil line can actually start causing bubbles in the jet tubes. Okay, so that's what, we don't want that air bubble like this slide is showing you to be in the nozzle assembly. Okay, these bubbles can start causing problems. Okay, so again, this is a cutaway of a normally operating pump except for the air bubble in the nozzle line. That this is in the nozzle assembly. Okay, the bubble is very small. It's been compressed to 100 psi in the nozzle line. So as we compress that bubble, it gets very, very small. As long as the pump's operating, the bubble remains small. It's compressed. It won't affect anything with burner operation. However, when we shut that burner off, the RPM decreases, the piston closes, okay, in other words, the regulator closes, cuts off flow of oil from the pump, but remember, there's no valve between the pump and the nozzle. Remember I talked to you about it's like the straw effect? We need to, basically, we shut off the flow of oil to the nozzle, but that oil holds because there's no air in there. Okay, but now I have an air bubble in there. So that air bubble can basically have taken over the pump for supplying pressure. So because of this air bubble, I'll get what we call that after drip coming out of the nozzle. So in other words, instead of having a clean shutoff here, where there's no fuel that comes out of the nozzle once the pump shuts off, this air bubble allows fuel to continue to drip a little bit out of this nozzle. And what did I tell you happens when fuel drips out of the nozzle? What do I start seeing?
Like a foamy mix.
Foamy mix is what I see when I'm bleeding the oil pump. Okay, that's what I'm seeing coming out of the bleed valve. But what do I see on the end of the nozzle when I start having a not clean shutoff?
It's like black, like real dirty.
It's like a black charcoal or coke-like substance that starts building up there. Okay? It will actually start building up. It looks like soot, but it's more like a carbon buildup that happens at the end of the nozzle because that unburned fuel doesn't burn. It just evaporates the moisture out of it because of the heat at that end of the nozzle. Okay, there's no ignition anymore. Okay, so that expanding bubble breaks that vacuum seal that we have on the remaining oil, and it's going to push it out of the nozzle. So we can't have any air in there. Okay, and as that continues to expand, okay, it's eventually going to empty that nozzle of all the fuel that's in there. The oil flow doesn't reach until the bubble has expanded back to its original size and the nozzle pressure has dropped to 0. The result is virtually no cutoff with a sooty, smoky shutdown. A solenoid valve won't help this because it's just not going to get rid of that bubble. Okay, it's a bubble thing. Okay, what's even more, okay, is that it affects the pump. Okay, so in the oil pump, this is the strainer area. So your oil pump has a strainer mounted on the side. The oil comes in, goes through the strainer before it goes into the pump. Okay, if we have air in here, okay, it's normal operation. It doesn't totally fill here, okay? The oil doesn't totally fill the strainer chamber because when you bleed it, okay, it just rises high enough to cover the inlet gear set. The air cushion at the top acts as a quieting agent, okay? In other words, it helps with sound. It actually helps with the sound of the hydraulic whine of the gears and doesn't affect operation. As long as the inlet to the gear set stays covered, everything's fine. But again, air bubbles in my oil system will start lowering the level, okay, of that oil level here. So if air enters the pump, it goes to the top and it pushes down the oil level in the strainer chamber, and it will start uncovering the inlet to the gear set. Okay, so air coming in the line will start uncovering this inlet to the gear set. Okay, as that inlet becomes more and more uncovered, okay, the gear set will start to gulp air and oil at the same time, and the pressure becomes unstable, resulting in poor combustion, noise, rumbling, and pulsation. Okay, this is one of the things you're going to hear us say quite a lot. Okay, noise and rumbling. Okay, if you have a noisy furnace, if you hear a slight rumbling out of the burner, okay, a lot of times it's a poor combustion problem. Okay, there's three things that causes combustion. It's called the triangle of combustion: air, fuel, and heat. All of that is required in perfect quantity. So if I have less fuel, if I have more air or less air, I'm not going to have good combustion. But unstable oil pressures cause the pulsation and rumbling and noise. If enough air enters the system, the oil level drops below the inlet to the gear set. Pressure is lost, and as soon as I don't have oil, and as soon as I don't have pressure, the burner will lock out. What locks the burner out? What causes the burner to lock out?
Solenoid or fuse valve?
What did we spend quite a lot of time talking about over a few days last week? What causes the burner to lock out?
High limit?
What device has either a sensing of the temperature or light sensor on it?
Picasso.
Yeah, my primary controls. That's what causes the burner to lock out. It's either a CAD cell relay or a stack relay. Okay? High limit will shut it off, but it doesn't cause a lockout. Okay? The other thing that happens, the other type of bubbles are gases. These comes from dissolved vapors that are drawn out of the oil when it's exposed to a vacuum. The higher the vacuum, the more bubbles are produced. This can be caused by high lift, in other words, a high vertical lift from the oil supply to the pump. It can be caused by long runs of oil pumping. It can be caused by undersized tubing, restricted lines, and most often partially plugged filters. Okay? Anything that restricts the oil flow can cause high vacuum, and it can actually boil some of the gases, some of the volatiles out of the oil and create bubbles. Okay, I want everybody to think back to, okay, for those of you who have had it, I want you to think back to either refrigeration or air conditioning if you've had it before. If not, I want you to think back to high school or middle school science. I know it's a reach, but I want you guys to think back. Someplace along the way, we had a conversation about you drop the pressure of any substance any liquid, you put it into a vacuum, you lower the boiling point. Okay, so I can boil water at room temperature by putting it into a vacuum. I can boil any liquid at a lower temperature by putting it into a vacuum. What's happening here is that oil is under a vacuum because the pump is sucking. If the vacuum gets too high, it's going to start boiling different components that are mixed in with the oil, and it's going to create bubbles. Because when I boil something off, it creates a gas. Okay, it does a change of state. We go from liquid to gas. So the higher the vacuum, the more bubbles are produced. You got to find out why the vacuum is too high. Okay, most often you have a plugged oil filter someplace. That's the most often problem. There's a restriction in the oil flow. The bubbles that are drawn out of the oil rise to the top of the strainer chamber, and eventually the oil level falls, and the gear set now has a little bit of a foamy oil. Again, it's internal to the pump. You can't see it. But the pressures became unstable, and the pump eventually locks out. The burner locks out. No piping arrangement can eliminate bubbles. One-pipe systems are simple. They use less material, prolong filter life by only passing the filter through the oil once. Okay, we can preheat the oil as long as it moves through the piping slowly, but they cannot deal with bubbles. Two-pipe systems are used for higher lift and can deal with some of the bubbles caused by higher vacuum. Okay, they're harder to install. It uses more materials. They load up filters much faster because there's constant oil movement through the system. The return line is pressurized, and the return line, if there's a leak, can cause some real environmental process. Remember, two-pipe system. One is under a vacuum, and one is under pressure back to the tank. Okay, you've got to be very careful about leaks. Okay? Now, the manufacturers of this device, of the oil pump de-aerator, tell us that this is the solution to all problems. Okay, this device that's in the center here, this is a de-aerator. Okay, it actually acts as a two-pipe system when we look at it from the pump. Okay, so the pump is set up to be a two-pipe system. One pulls my oil supply out of the de-aerator, which supposedly has no bubbles in it. Okay, so the oil comes to the pump. The other side returns the oil to the de-aerator through a return line. The only time oil is pulled from the tank is when the de-aerator doesn't have enough oil in the tank. Okay, that's when the oil is pulled to the tank. Anybody have any questions on looking at this screen at how this goes into a system?
No, sir. Nope.
Okay. Okay, again, this is a little bit off the slide, but it's basically, okay, we move oil. The only oil moving to the inlet line is what's going to the nozzles. So filters last longer, and the oil will preheat to an ambient temperature before reaching the pump. Between the de-aerator and the pump, it's a two-pipe system, as I just showed you. Okay, between those two components, it's a two-pipe system. Self-primes everything else, handles high lift capacity of a two-pipe system. Okay, again, long high lift jobs are possible because the flow rate from the tank is low. I'm not moving constant oil out of the tank. Any bubbles are handled by the de-aerator. Okay, so because of the vacuum, the bubbles are handled by the de-aerator. It removes the bubbles. The actual piping of the de-aerator is quite easily. Okay, this is an example of a single pipe system. Okay, it shows a single pipe system, gravity fed, which is a good candidate for a de-aerator. Okay, so in other words, I have one pipe coming out through my filter to my pump inlet. I don't have a return to the tank. Okay, mount the de-aerator in a convenient place close to the burner. There's actual flexible oil lines. Okay, we want to use flexible lines. Anytime I use a flexible oil line, what does it prevent?
Ooh.
What does flexible lines prevent, like a woven line? Noise and vibration. Okay? We have to put that bypass plug into the pump. Remember I told you about a little plug that has to go into the oil pump that has to be installed before connecting the lines. The pump must be set up for two-pipe operation or it doesn't work properly. Got to have it set up for two-pipe operation. Okay, so when it's all connected, that picture that I showed you a few minutes ago or 2 slides ago looks like this. Okay, so the line from my pump is coming, or my tank is coming through the filter to the de-aerator, and then out of the de-aerator, I have 2 lines. By the way, the brand name of the de-aerator is called Tiger Loop. Okay? And again, it's just the whole purpose of this is to get rid of oil bubbles. We do not want oil bubbles into the tank or into the burner or the nozzle. Okay? A 2-pipe system can also be converted to a de-aerator using the same steps outlined up above for the 1-pipe. The bypass plug is already installed. Make sure the old return line, which will no longer be used, is capped off and sealed. Has to be leak tight. You're only going to use one line. You're going to use the supply line from the tank. It's no longer being used as a 2-pipe system. So this is your 2-pipe system before we install the de-aerator. Okay, we have one line that's a supply line. We have another line that's a return line. When you install the de-aerator, you're capping off that return line. It's no longer used. It has to be sealed, preferably removed, but at least sealed. Okay, and we're now using the de-aerator in its place. The biggest place where I see value in de-aerators is when you have an underground oil tank that you're not 100% sure of that return line and you're not 100% sure how deep into the tank that supply line goes. And you might get air every once in a while, causing random lockouts. That's the only time I really believe in using de-aerators. I don't like them. I think they're sloppy. But a lot of people out there use them, and that's why I want you to know about them. Any questions on de-aerators?
Nope.
No, sir.
Okay. One more thing, small thing, that I want to a little bit talk about, okay, is let's go ahead and have a brief discussion about where you find this stuff in NFPA. We can't get away from NFPA. We still have to talk about NFPA, and I realize code is probably one of the boringest things we can talk about. Okay, piping and system components are talked about in NFPA Chapter 8. I'm not going to spend a ton of time on this, but I basically want to show you where some of the things are in Chapter 8. So Chapter 8 of the NFPA 31, which is all about fuel oil, talks about the system piping and the system components. Okay, we start talking about the acceptable piping methods. What is acceptable from types and materials in section 8.2. Okay, and it refers you, as always, to other types, other systems. Okay, so again, chapter 8.2 is all about what is acceptable from a piping material. Okay, 8221 talks about above ground fuel supplies, what you can use. Then we talk about underground fuel lines and what we can use. Okay, and it refers you to other UL codes, fuel oil codes, okay, and other codes. But basically it has to be able to withstand either above ground or underground, okay? So we have all of that. 8.3 talks about the fittings. Okay, fittings are any connections, anything the piping connects to, okay? Has to be flare fittings. Okay, it talks about that you have to use either liquid tight fittings or sealing compounds. Now, pipe sealant, does everybody know what that is? Pipe sealant.
Yes.
Did you know that there's different types of pipe sealant for different uses?
That I didn't know.
Yeah, there is. It's based on the color. Okay, believe it or not, the color of the pipe sealant out there tells me what it can be used for. Yellow pipe sealant can never be used with oil. Let me repeat that. Yellow pipe sealant can never be used with oil.
That's for gases, right?
That's for gas. Okay, blue is normally what we see on oil. Blue goop. Okay, so never use yellow. It will fail inspection immediately. Okay, it's only for yellow's only for gases. Okay, and of course 833 basically says if a mechanical engineer told you to use a different type, and if the mechanical engineer is a licensed mechanical engineer and has designed a system that is a specific design, okay, you can use other types. Cast iron fittings shall never be used. Why don't we use cast iron fittings on oil? What's important about cast iron?
It's also for gas.
Iron rusts.
Iron does rust.
Chip?
Iron, has anybody ever seen something that's older iron that's broke, that cracks?
Yeah.
Cast iron has a habit of cracking over time. Okay, so we want to be very careful with cast iron. It doesn't expand and contract very well, especially if it's screwed into steel. Steel doesn't expand and contract as much as the cast iron and stuff like that do. So just again, cast iron fittings cannot be used. Okay, 8.4 talks about piping system design. Again, piping system should be liquid tight, should be supported, needs to be protected, has to handle expansion, contraction, jarring, and vibration. Okay? Has to handle a 30-minute fire rating. In other words, it has to be able to stand up to 30 minutes of high intense heat without it breaking down or melting. Okay? So again, underground tanks talks about where the connections can be made. Okay, we can't transfer fuel through piping to an appliance by pressurizing the tanks. Okay, every tank should be equipped with separate fill and vent pipes. Okay, and of course the vent pipes need to terminate above ground outside the building. Hey, what's the point of a vent pipe if it just vents into someone's basement? Okay, gases come off of there, combustible. Okay, talks about the size of the fill pipes. I mentioned this to you yesterday as well. All of this is in Chapter 8. Okay? So again, end of the fill pipe should be equipped with a tight metal cover. Okay, and should be identified as the heating fuel fill opening. Vent piping, pitched towards the tank, protected from damage. No sags or traps where liquid can collect. Has to have an audible alarm at the tank opening. Terminates outside the building. Okay, not more than 12 feet from the fill pipe, and they have to be visible from the fill point. Okay, So again, talks all about the piping, fuel supply, piping, and return. At least 3/8 inch piping or tubing. At least 3/8 inch tube piping or tubing. Does that mean it can be larger than 3/8 inch?
Yes.
Yeah, if the appliance is going to take more oil than can be delivered in a 3/8 inch tube, it can be larger than 3/8 inch. But it has to be at least 3/8. Has to have a shutoff valve at the outlet. Okay? Has to have a shutoff valve if there's an underground tank. Okay, in other words, put a shutoff valve on it. Has to have a readily accessible fusible link, okay, as close as practical to the burner supply connection. In other words, fusible link. If it heats up, if there's a fire, it closes. That's the firematic valves. Okay? Has to have a fusible link. The pressure of a fuel supply inlet to an appliance will not exceed 3 psi unless the appliance is approved for a higher inlet pressure. Okay, and that's tank pressure. We don't pressurize tanks. That's just the weight of the oil. Okay, 875 continues, okay, continues to say about how things should be put together. Okay, unions or fittings that require gaskets will not be used in fuel lines. Fuel return piping, a return line from a burner or pump back to a supply tank doesn't have any valves. Okay, if there's an auxiliary tank, okay, if there's an auxiliary tank, it has an overflow pipe that drains back to the supply tank. That overflow pipe will not have any valves or obstructions. Okay? If you have two tanks, they're called cross-connected tanks. Okay? And they cannot be more than 660 gallons total capacity. That's all that's allowed if you have cross-connected tanks. Tells you exactly how you can put them together. This all has to do with fire prevention. If you have 3 tanks, it cannot be more than 990 gallons. And again, you can only connect 2 together from a crossover. Okay? Tanks can't be larger than 330 gallons if they're in someone's house. Can't have larger than that. But you can have multiple.
So that third tank has to have its own connections?
Has to have its own fill and vent, yeah.
Okay.
Okay. Yeah, it all has to do with fire protection. Okay, and again, you can have 4 tanks, but you can only have 2 twinned together. Goes along with that last picture. You see how this one now has the 2 twinned? Okay. I can't twin all 4 of them together. I can't connect all 4 of them.
Where would you actually use 4 tanks? I mean, besides commercial, that I assume.
I like commercial. I've never seen it in a house. I have seen 2 tanks. There are some areas, if you think about some areas of even, think about the northeast corner or northwest corner of Connecticut, think about western Massachusetts, think about the Berkshire regions. There are some areas where it's very difficult to get oil trucks in during the winter months.
Okay.
Okay, so if I can fill up tanks and have all my fuel on site before I go into the peak winter months where there's a ton of snow and it's dangerous to get the oil trucks in, I'm better off doing that.
And so that would be the only reason a resident would have more than 2 tanks. or more than one?
More than one, yeah. Okay.
Okay.
And of course now there's also some people are believe it or not, I got a call from a friend of mine who does oil up in the Connecticut, and he's had a number of people recently ask him for a second oil tank. And again, there's a little bit of a concern about whether or not they're going to be able to get deliveries during the coronavirus. I don't understand why this is a concern, but there's concerns about getting supply chain. Okay, and I've seen people want to install a second oil. I've heard of this recently. Of course, here in Florida, we don't do oil, so that's. But I talked to a friend of mine recently who's had a run on second oil tanks for some reason.
And they're just preparing for the coming apocalypse.
Yeah. We won't get into that conversation here. Okay, so cross connection again has to be done per code. All fill and vent pipes drain to the tank. Okay, and vent pipes from more than one tank can be manifolded and connected into one outlet tank. Okay, outlet pipe has to be at least one pipe size larger than the largest individual vent pipe. In other words, if you connect two or more vent pipes together, the connection has to go to a larger pipe. Okay, 8.10 talks about pumps, valves, gauges, and everything else having to do with it. Okay, we just need to make sure that any gauge does not discharge fuel or vapor. We're very concerned about the vapor coming off oil tanks because vapor is flammable. I can't burn a liquid, but I could sure burn vapor. Okay, so anything we have on the oil line cannot allow vapor to come out of that tank. Okay, so again, we just got to be very careful. It talks about how to determine safe fill levels. Okay. Audible warnings. Supply tanks shall not be equipped with a glass gauge. Why don't I use glass as a gauge?
The pressure could burst the glass.
Yeah. It used to be, believe it or not, that on the wall, if you had an oil tank that was underground outside, on the wall of your basement closest to the underground oil tank, you used to have a glass gauge that actually showed you the level of the oil that was in the outside tank. It was just a column. It was a straight up and down vertical glass gauge that basically duplicated the oil level in the tank outside. Okay, those things, if someone ran into it, if it broke or if it started leaking, it gave a direct path of oil to come into the basement. Let's just put it that way. It's not a good idea. Okay. Testing of fuel supply piping, okay, needs to be done. Okay, we need to isolate the supply tank and any fuel burning appliance. In other words, the valves need to be closed to the burner, okay, in the tank. And then what we do is we can do either a pressure test and hold it for not more than 10 minutes, okay, at 5 psi to 10 psi, not of at least 5 psi, but not more than 10 psi. Okay, and you can use soap bubbles or an equivalent leak detection to test all the joints. Okay, a vacuum test, okay, can be conducted with a vacuum pump and a vacuum gauge with at least 0.5 inches mercury. Okay, and the vacuum should be held for at least 30 minutes after the stabilization with no loss. Okay, vacuum of at least 20 inches mercury should be applied to all portions of the supply pipe, okay, to be evaluated. We need to get to 20 inches mercury, and it tells you exactly what the vacuum gauge shall be. Okay, has to have 5 inches, 0.5 inch increments, and we have to hold to 20 inches of mercury, and it has to hold for 30 minutes. Do you think an inspector is going to look at this?
Oh, yeah.
Yeah, most building inspectors want to see that vacuum. Okay. I have rarely been asked to see the pressure test, but I have been asked to see the vacuum test a lot of times. Okay. Okay, gauges have to be in working order. In other words, when you show up to a job site, okay, and put that gauge on, the inspector's going to want to see it before you put it into a vacuum and then after you put it in a vacuum. Why does the inspector want to see the before you put it into a vacuum?
I assume it can cause a lot of damage.
Well, there was a time and age where there was some oil burner techs that didn't totally, and this happened actually in Waterbury about 15 years ago. A bunch of oil burner techs, this code became a requirement about the vacuum test. They used to just do pressure tests. The technicians didn't want to do the vacuum test, so they readjusted their gauges to always show the 20 inches of mercury. So no matter what system they put their gauge on, it always showed 20 inches of mercury. So the inspectors got wise to this and wanted to see the vacuum gauge before it was put on the system to make sure it was showing 0. And then when the technician put it on the system, it showed a 20 inches of mercury.
Oh, okay.
Okay, it was to prevent technicians from just having their gauges preset. Okay, I still don't understand why somebody would do that, but that's the reasons. So, any questions on anything that I've gone over today? As I said, today was a little bit of a shorter than normal. Tomorrow I'm going to talk about nozzles. Okay, tomorrow is all about nozzles, and it will go a little bit longer than we had today. So any questions on today's material?
Nope.
I'm good.
Well, I'm good too. So you guys have a great rest of the day. Barry, hang out for a minute if you would.
You too.
Yes, boss. See you tomorrow.